binomial together. And notice that our friend FOIL is gone now because we can't use FOIL in this case here. But instead what we're going to do is just think back to the distributive property, and we're just going to distribute this 2x into every single term here. And then once we're done with that, we're going to take the 3 and then distribute that into every single term that we see. So really what we've been doing the whole day is really leads off the distributive property really. So this 2x is going to get distributed into every single term in that parenthesis, which is the x squared, the x, and the negative 1. And since we're done distributing that guy, we move on to the 3. So that it has to get distributed into every single term also. So the 3 has to go into the x squared, into the x, and negative 1 as well. So let's see what this is going to look like. So 2 times a 1, because there's technically a 1 here, right? That would give us a 2. X to the first power, x to the second power, that would give us an x cubed. So multiplying the 2x into the second term, we would get a 2x squared, right? X times x, and the 2 being there. Finally, the 2x times the negative 1 would give us a negative 2x. So we have completely distributed that 2x into every single term there. Now we move on to the 3. 3 times x squared would be 3x squared. 3 times an x would be a 3x. And finally, 3 times the negative 1 would be a negative 3. So now we just want to group everything together. Not really group, we're just trying to combine like terms. So I'm just going to write these guys that have the second power next to each other, and then these guys that share the x next to each other. So we're going to get the 2x cubed. There's no other anything to the third power, so this guy has no partner to combine with. So there's the 2x squared and the 3x squared. I'm just going to write them next to each other. And then I'm going to write these 2 x's next to each other also. So we have a negative 2x and a positive 3x. And that's the only constant left. So when you combine these second degrees together, so the 2x cubed stays, 2x squared plus 3x squared would be 5x squared. So there goes that. Negative 2x plus 3x would give us an x. And finally you have the negative 3 left over. So this should be your final answer, 2x cubed plus 5x squared plus x minus 3. Alright, so this is just like the previous example. You got a binomial and a trinomial getting multiplied together. So same thing. We're just going to distribute the a into every single term we see there. So 1, 2, 3. And once we're done with the a, we're going to move on to the negative b. And again, just beware of the sign there. That's very important. You're going to distribute not only the b, but the sign associated with it, which is the negative. So we're going to distribute the negative b into all 3 of those terms as well. Just like that. So let's see what we get. You have a times a squared. That would give us a cubed. A times ab. That would give us a squared b. And then a times a b squared, that would give us ab squared. And that's it for the first term. Moving on to the second term, you have a negative b being multiplied with a squared, which would be a negative a squared b. Doesn't matter if you write the b first or the a first. I just did it in that style. So then moving on, negative b times ab. The b's would combine to give you a b squared, right? So you get a negative ab squared. And finally, negative b times a b squared would give us a negative b cubed. And then you just want to see what you could combine together right now. So you have the a cubed and the b cubed. You can't really combine those. I mean, they don't have anything in common to combine with. So the a cubed and the b cubed, I'm just going to write them as is. There's an a squared b here and a minus a squared b here, right? So those just cancel out as is right now, right? So the a squared b and the negative a squared b cancel out right now, right? And then also there's an ab squared and a negative ab squared. So those also cancel out as well. we happen to get lucky in this example. So we just get a cubed minus b cubed for this example. Okay, so why don't you guys go ahead and give this a shot. It's just like the other examples we tried. It might look harder, but if you just stick to the same thing we've been doing, you'll be alright. So give that a shot, and then I'll go over it with you. Alrighty, so I'm just gonna use the think like it's distributive property and distribute this x squared into each of these terms here. So I'm going to distribute into the x to the fourth first, next into the 2x squared, and finally into the negative 5. And since I'm completely done distributing that guy, I'm going to move on to the 1 and distribute that into every single term as well. So let's see what this would look like. X to the fourth times x squared, that would be x to the sixth. X squared times 2x squared, that would give us a 2x to the fourth. And then x squared times the negative 5 would give us a negative 5x squared. And that's me distributing the x squared into everything there. So then I move on to the 1. Now when you multiply anything by 1, it just turns out to be itself again, right? So 1 times the x fourth. 1 times the 2x squared. And then finally 1 times the negative 5. And now we just want to see if we could combine any like terms now. So x to the 6th, there's nothing else to the 6th power, so I can't combine anything with that. But here I see that I have the 2x to the 4th and the x to the 4th here. So before I combine them, let me just write them next to each other really quick. You don't have to do that in the future, I'm just doing that for this video. So I just put these guys next to each other, and then I noticed there's a negative 5x squared and a 2x squared. So before I combine them, let me just write them next to each other again. Okay, so now that we do the combining with the x to the 4th, you have x to the 6th, 2x to the 4th plus 1x to the 4th, that would give you 3x to the 4th. So there's those guys. That's an ugly 4. Okay, you have a negative 5x squared and a positive 2x squared, that would give you a negative 3x squared. And then finally you have the constant left over, which is the negative 5. So I got x to the 6th plus 3x to the 4th minus 3x squared minus 5, and hopefully you got the same answer. Okay, so this is the last example of the day. We have x plus y, and that's going to get multiplied into x squared minus xy plus y squared. So go ahead and give that a shot, and then I'll go over it with you. Okay, so assuming you gave that a shot, first going to take this x and distribute it into each of these terms here in this parenthesis, like that. Then once I'm done doing that, I'm going to move on to the y and distribute that into every single term as well. So let's see what happens when we multiply those together. X times the x squared, that would give us an x cubed. X times a negative xy, the x's would combine to give us an x squared, and the negative is there, so negative x squared y. And then finally, x times the y squared would be a positive x y squared. So we completely distribute the x into each of those terms. Let's move on to the y. Y times x squared would just be yx squared. Then y times a negative xy. The y's would combine to give you a y squared, and there's a negative there. So negative xy squared. And then finally, y times a y squared would give you a y cubed. And now we just do the combining part. So there's the y is to the third term, but you can't combine them because they're different variables. So this x cubed, I'm just going to rewrite. Can't combine with anything. There's a negative x squared y here, and there's a positive x squared y here. So those would cancel out. Negative x squared y, positive x squared y. And then here you have a positive xy squared, and here you have a negative xy squared, so those would also cancel out. So we just end up getting x cubed plus y cubed plus y cubed. So we ended up getting lucky on that example as well. A lot of stuff have to be canceled out. So thank you guys, and hope to see you next time.